In this video, we're going to be finding the initial amount of an investment earning continuous compound interest. Okay, so here's our formula for continuous compound interest. A is equal to P times E to the RT. A is the amount after time. P is the principal. It's the amount you start with. E is a constant. R is the annual rate of interest. And T is time in years. Okay, so Mr. and Mrs. Coleman hope to send their daughter to college in 14 years. How much money should they invest at an interest rate of 8.5% per year, compounded continuously, in order to contribute $9,000 to her education? Okay, so we know the rate. The rate is going to be 8.5%, okay, which we will write as a decimal. 0.085 is our rate, okay? And then we know the time, 14 years. So T is equal to 14. And we know what we want to end up with. So it says continuously, or compounded continuously in order to be able to contribute $9,000. So this is the amount after some time has passed. That's their A. So A is equal to 9,000. Okay. So how much should they put in now in order to get 9,000 back? So what we're looking for is P. That's the only unknown. Okay. So we get 9,000 in place of A equals P. That's unknown, times e to the r, which is 0.085, times 14, which is your time. Okay, so that will give you 9,000 equals p times e to the 1.19. Okay, so e to the 1.19 is a number. You could type that in your calculator. But before we do that, let's go ahead and just get p by itself. So let's just divide by that on both sides. Divide by the e to the 1.19. So that gives us that p is equal to 9,000 divided by e to the 1.19. Okay, now this we have to take to the calculator. Okay, so let's go to the calculator and type in 9,000. Your E can be found by hitting second LN on a TI-84. Oh, I should have hit divide first, so let's go ahead and put that divide symbol in there. And E to the 1.19. So 9,000 divided by E to the 1.19. And we get approximately, because this is money, so we're just going to go to two decimal places. We'll round. The one is not going to make it round up. So we get approximately $2,737.99. Okay, so that's about how much they need to put in for 14 years in order to get $9,000 out. Okay, let's look at this one. How much money should be invested now at an interest rate of 6.5? So R is equal to 6.5%, which is equal to 0.065 as a decimal. Compounded continuously, so we're using the A is equal to PERT, P-E-R-T. So to have $2,500 in 4 years. So this is the amount after some time. That's A is equal to 2,500, and T is equal to 4. Okay, so we get 2,500 equals E to the 0.065 times 4, which is, whoops, I forgot my P, which is 2,500 equals P times E to the 0.26. Okay, so when we solve this for P, divide both sides by E to the 0.26. Okay, so that gives us P is equal to 2,500 divided by E to the 0.26. Okay, so let's go ahead and put that in our calculator. 2,500 divided by E to the 0.26. Whoops, I did not type in my 6. There we go. Okay, so $1,927.63 because we're going to round up. Okay, so P is equal to $1,927.63.